All right, so let's go ahead and go over solving exponential equations level one. All right, so what we're going to do, I'm going to walk you through some simple examples first of how to solve exponential equations just with some basic information, right? So we want to be able to understand what's going on. So we have 3x plus 2 is equal to 3 to the fifth power, right? So we've been working on exponentials. We've been working on exponential rules recently. So we do understand at this point that when we have bases that are the same, that exponents are equal to one another. So now all I have to do is set my equation, x plus 2 is equal to 5, and solve for x. How do I solve for x? From here, I just say, hey, I'm going to subtract 2 from both sides, not 5, right? And then that will give me x is equal to 3, right? All right, another problem. We have 2 to the x minus 3 is equal to 8. So what's that's going to allow us to do, we have to be able to see, hey, if I don't have the same bases, what do I have? Well, I do know from my multiplication facts that 8 is nothing but 2 to the third power, right? Since 8 is 2 to the third power, I could rewrite this as a base 2, right? So x minus 3 is equal to 8 to the second power, 2 to the third power, excuse me, right? And so now I have the same base. So again, I can set my exponents equal to one another. So that means after I add 3 to both sides, x is going to be equal to 6, right? All right. All right, let's see an example when we don't have bases that are the same. What do we do? And so right here, right now, we have 2 to the 2x, and that's equal to 5. Well, we know with this equation, I can't make 5 be a base 2. So now we want to be able to introduce our natural logarithms, right? So our natural logarithms are going to give me log of 2 to the 2x equal to log of 5. Now, what this is going to do for us, this is going to turn this into numbers, and we're going to get rid of all exponents. So right here, right now, what I can do is I'm now going to take this 2x, that's my exponent, and now I can bring it to the front and multiply it by log of 2. So I will have 2x is equal to the log of 2 equal to the log of 5. And just for reference, anytime we're taking a log of something, the base is 10. So we're changing the base totally, which allows us to be able to work with it as a number. So now we have 2x log 2 equal to log 5. Well, now we can divide both sides by log of 2. And we'll have 2x is equal to log 5 divided by log 2, right? And so now from here, I still want to get x by itself. So now I just divide everything by 2, and I have x is equal to, and let me just do 1/2 just for the sake of space, times log 5 divided by log 2, right? And how would I type that into my calculator? Let's go ahead and go to our calculator. Let's clear it out. And so what I would do, I would type in log 5 divided by log 2 equals, and then I will multiply that by 0.5, right? And I'll get 1.16. Now, let's say, for instance, I wanted just to divide that answer by 1/2. I will put it in parentheses, 1 divided by 2, and I'm going to get the same answer, right? All right. And so this is the basis on how we want to answer some of these questions. And so now let's go ahead and go to Delta Math to figure out how we want to approach these problems. So now we have 2 to the 4x equal to 8, right? And so we remember from earlier when we worked on that problem, we know that 2 to the 4x is going to give me 2 to the third, right? And so that means 4x is equal to 3, x is equal to 3 over 4. So now I can still use my natural logarithms here, right? So it doesn't hurt to use the natural logarithms if I want to. And if I want to, I'm going to end up having 4x be equal to the log of 8 divided by the log of 2. And then I want to end up dividing this. I want to end up dividing this by 4. And so x is going to end up giving me 1 over 4 times log 8 divided by log 2. And we're going to type these two answers into our calculator to kind of show that we're going to get the same answer, right? So we know the first one is 3 over 4, right, which is 0.75. So we're going to type this 1/4 log 8 divided by log 2. So again, we're going to do log 8 divided by log 2, and we're going to multiply that by 0.25, right? And that's going to give me 0.75. So again, it doesn't matter which way you do them. If you find out that I can make the base the same and then use my exponent rules or my natural logarithms, right? We want to just try to save the natural logarithms for when we have different bases, right? Because it's just a lot harder to find the different bases, right? All right. So now let's approach another problem here. All right. And so now what we have here on the screen is we have 10 to the x over 3 equal to 20. All right. So now I can make these be the same base, right? But I don't want to. I want to learn how to do logarithms, right? And so right here, right now, I'm going to take the log of this function. So I'm going to take the log of 10 to the x over 3 equal to the log of 20, right? I know this is going to come to the front. So I have x over 3 times log 10 equal to log 20, right? Then I'll have x over 3 is equal to log 20 divided by log 10. And then what I'll end up doing is I'll multiply 3 by both sides. And I'll end up with x is equal to 3 log 20 divided by log 10, right? And so once we find our answer, I want to show us a little trick on how we can rewrite these, right? So we're going to go to our calculator, right? And we're going to have log 20 divided by log 10 times 3, and we go get 3.9, right? Well, let's say, for instance, based upon this answer, I accidentally typed in 3 log 20 divided by log 10, right? So we have 3 log 20 divided by log 10. And we get the same answer, right? So whether I'm writing 3 log 20 or 1/3 log 20 divided by log 10, if I'm multiplying a whole number, it could go on the numerator. If I'm dividing by a whole number, that whole number could go in the denominator. So for example, I'm multiplying here by 3. So I could say it's 3 log 20 divided by log 10. If I was dividing here by 3, I would say log 20 divided by 3 log 10, right? Because again, if I'm multiplying by a fraction, I can just put that denominator of one fraction with that log and vice versa, right? But that's just for some simplicity. So right here, right now, we know our answer would be 3.9, right? All right, we'll go ahead and do one more just for clarity, just to make sure we understand what's going on. All right, right here, right now, what we have is 2 times 3 x to the x over 5 equal to 1. So anytime they write an equation like this, that means we're dealing with base 3, right? So when they show us 2 times 3 to a power, that means the base is that second number, right? So here our base is 3. We're not multiplying 2 times 3, right? Our base is 3. So right here, right now, what we want to do, we want to go ahead and divide by 2 on both sides, right? So we end up having 3 to the x over 5 equal to 1/2, right? Take the natural log of both sides, and we end up with x over 5 times log 3 equals to log 1 over 2, right? And so now I have x, after doing some algebra, I know I'm going to multiply both sides by 5. So then I have x is equal to 5 log 1 1/2 divided by log 3, right? So now we can go to our calculator. We go 5 log 1/2 divided by log 3. So we have a negative 3.15 here, right? And that's our answer, right? And so I do want to find one more problem. So let's try to do a problem with E in our equation. All right, now what we have here, we have E to the x over 5 equal to 12, right? And so with E, we want to take the ln, not the log. We want to take the ln. So now what we're going to do is we're going to take the ln of E equal to the ln of 12, right? I still want to multiply that by x over 5. It's still going to be the same. The reason why I want to do that is because this value here is equal to 1. So anytime we do the ln of E, that's equal to 1. So anytime I see E, I want to do the ln of E, right? So then I will just have x over 5 is equal to the ln of 12, right? Then we multiply both sides by 5. And I can literally put this just like this in the calculator, right? So I'm going to go to my calculator, and I'm going to put 5 ln 12, and I have my answer. So my answer here will be 12.4, right? Rounded to the nearest hundredth. So let me go back. 12.42 would give me my answer. So we'll go ahead and type in 12.42, hit submit answer, boom, and that's going to give it to us, right? So again, I know it says log of E on the screen, but however, I do know personally that ln of E is just 1. So if I go back to my whiteboard and my notes, ln of E is 1. So anytime I'm dealing with ln of E, this is the approach I want to take, because it kind of simplifies everything for me, right? And again, hopefully this helps you guys. If you got any questions, please don't hesitate to reach out.